Hi, this is a video to show you how to take existing fractions and break them into what are called partial fractions. You use this in calculus when you have a fraction that you need to integrate and it's very complicated and you're wanting to split it up into simpler things that are easier for you to manage. The premise of this will start with the degree of the numerator being less than the degree of the denominator. And if it's not, then we'll use long division to rewrite it into quotient plus remainder over the denominator. And then we'll use the partial decomposition on this fraction part that's left over. So I'll show you an example of that when we need to use long division. But to start, I want to give you just some of the basics of what the idea is. So sort of background information. If I had a fraction, if I had two fractions, let's say 3 over x plus 5 and 7 over 2x minus 1, and I wanted to combine them together, I would need them to have common denominators. So I would multiply the one on the right by x plus 5 over x plus 5. And I'd multiply the one on the left by 2x minus 1 over 2x minus 1. And then we would get 6x minus 3 plus 7x plus 35 over 2x minus 1, x plus 5, or 13x plus 32 over 2x minus 1, x plus 5. And the denominator might even be multiplied out. We're going to be kind of going backwards from what I just did. We're going to be starting with this fraction, and then we're going to be breaking it apart into these two fractions that we were given originally. So we're going in a backwards fashion, breaking it into more simplistic fractions. Now, some of the formatting that we need to think about. Has to do with what the denominator looks like. So suppose that I have something like this, x plus 2 squared. This is a linear factor. What's inside parentheses is linear. And when we set up what the fractions are going to look like, we have the numerator set with 1 degree less than the denominator. Right now, the denominator has degree 1, and so the numerator is going to have degree 0, which is just x to the 0 power, or a times x to the 0 power. We don't typically write x to the 0 power because it's just equal to 1, so we're just writing some variable. We don't know what that variable is, but we're going to go through a process to figure out what the value of a is. And then the second fraction is going to be a plus 2 squared. So I'm going to filter through all the possible exponential values that I can have for the denominator, and both the numerators are 1 degree less than the denominator. A second type of example would be, let's say that I have 5 over 4x squared plus 3, and then this is raised to the 3rd power. Now what I have here in the parentheses is a quadratic. And so that means for the numerator to be 1 degree less, it's going to be a linear factor. So similar to what I had before, I'm going to filter through all the possibilities of what could end up in the denominator, taking that quadratic to the 1st power, taking it to the 2nd power, and then taking it to the 3rd power. And then the numerator is also going to be variables of which we'll figure out what the numbers, what the number values are for them, but it's going to be linear. So it's going to be ax plus b. And then I have to have different variables for my second fraction. So I'll write that as cx plus d. And then fx plus g. Different variables, each 1 degree less than whatever's in the denominator. So I'll go through examples and show you the process to figure out what all of the variables are equal to, a, b, c, d, f, g in this case. Okay, so for our first example, let's find the partial fractions of x plus 7 over x minus 3 and x plus 2. Now I have two different factors in the denominator, so they'll each get their own fraction. And then the degree of both of those is to the first power. And so what's in the numerator is going to be to the 0 power. So I'll put a variable a here, different variable here of b. Now, again, to make these all the same denominator, I'm going to multiply that first fraction by x plus 2 over x plus 2. And then the second fraction will be multiplied by x minus 3 over x minus 3. So multiplying this out, I have ax plus 2a plus bx plus minus 3b over this denominator, x minus 3, x plus 2. Now, because the denominators of both sides of this equation are the same, I don't need to worry about them anymore. I'm trying to figure out what the value of a and b are, and really all I need to do is look at the two numerators. So I'm going to now just focus on the numerators. X plus 7 is equal to, I'm going to put ax, I'm going to put the two x's together, and then I've got 2a minus 3b. Now, the way that this is written, these two are the first part, right, of the equation. That's got to be equal. And then these two are the second part of the equation. So that's got to be equal. So what I have is that a plus b has to equal 1, right, because technically there's a 1 here. And 7 is going to be 2a minus 3b. So now I've got a system of equations to solve. I'll rearrange the first one. Let's write this as a equals 1 minus b, and then substitute it into the second. So I'll have 7. Oops, let's do this. 7 equals 2 times, we'll put 1 minus b here, minus 3b. Or 7 equals 2 minus 2b minus 3b. 7 equals 2 minus 5b. I'm getting that b is equal to -1. And so then if I take that and plug it back in here, -1 in here, I'm going to get that a is equal to, let's see, that'll be equal to 2. All right, so I found the two coefficients. Let's go back to our original here. Let me copy this and paste it. That's not going to be big enough. Let's see. No. Hang on, I'll get it. Oh my goodness, come on. I'm trying to be crafty and it's not working. I'll just make this bigger. Okay. Copy. erased. So we know that A is, what did we say? I erased it, 2. And B is -1. So I'll change this to a minus. And I'll change this to a 1. And so this is our solution. All right, let's do another example like that, one that's a little bit more complex. Let's find the partial fractions of x squared minus x minus 4 over x minus 2, the quantity cubed. So for this example, I'm going to have 3 fractions. The first one will have x minus 2 to the first power, and then I'll have x minus 2 to the second power, and then I'll have x minus 2 to the third power. And in the numerator, we'll go 1 degree less than the denominator, which is just going to be to the 0 power. So A, B, and C. Now to get these denominators to be the same, this first fraction is going to be multiplied by x minus 2 squared, right? I need to have each of these to the third power. And the second fraction is going to be multiplied by x minus 2 to the first power. And the third one can stay as it is because it's already to the third power. So I'm going to have A times x minus 2 squared plus B times x minus 2 plus C. And that's going to equal the numerator. I'm kind of skipping a step here. Rather than rewriting all the fractions, I know that what I'm trying to do is just make the denominators the same so that I can take them out of what I'm focused on and just look at the numerators only. So I'm going to, well, one of the techniques that we use often is if we can let something sort of zero out, it helps us maybe find one of the variables more simply. So for example, if I let x equal 2, over on the left-hand side, I'm going to have 4 minus 2 minus 4, which is -2. And on the right-hand side, this is going to be 0. This is also going to be 0. So I just have C. It's kind of helpful. I was able to find pretty quickly one of the variables already. C is equal to -2. Right? So let's go back and I'm going to go back to this part here and rewrite it again. Let's say x squared minus x minus 4 equals, and I'm going to multiply out what I have here on the right. I've got A, this is x squared minus 4x plus 4, and this is x minus 2. And then I've got, let's put our minus 2 there because we know what that is already. So ax squared minus 4ax plus 4x plus 4 or bx minus 2b minus 2. So I can see that here, this part here has to match up with this part. And then this part here, these are all the items that have x's. Oops, this should be an A. Let me just double check here. Ax squared minus 4ax plus 4a. There we go. I need to rearrange those then. Let me rearrange these. Well, I'll stay right here. The only thing that has a square in it is this ax squared. So I think I feel confident at this point saying that a is equal to 1, right? Because it's got to match up with what's over there on the left-hand side. So let's rewrite this equation again using what we now know for a and c. So I've got x squared minus x minus 4 equals since a is equal to 1, I've got x squared minus 4x plus 4 plus b times x minus 2 times b minus 2. Right. I'm going to get rid of these two because we don't need them anymore. And then I have, let's see, negative x minus 4 equals, I'm going to put negative 4x. Wait a minute. That should be 4ax. Oh no, that's right. Negative 4x plus bx. Those are anything with x's, and then I've got over here plus 4 minus 2b minus 2. So what I'm doing is I'm kind of saying, okay, these have to equal to this, and this, which is all just going to be numbers, has to equal to this. So let's just look at what I have in green right now. Negative x equals negative 4x plus b. So if I add 4x to both sides, I've got 3x is equal to bx. So I'm getting that b is equal to 3. And now I think I'm done, right? I found A, I found B, I found C. Excellent. So my original, way back up here, let's see if I do this right this time. I'll just grab a bigger chunk. So we said that B was 3. We said that C was negative 2. And A was equal to 1. So this is our partial fraction decomposition. All right, let's do one example where we have to divide out. I'm going to get a new piece of paper here. This is probably getting long. So let's find the partial fractions of 10x cubed minus 15x squared minus 35x over x squared minus x minus 6. Now, what I was saying at the very beginning is that we need the degree of the numerator to be less than the degree of the denominator, and that's not the case here. So we have to do some division to start. This is going back, way back to sort of the beginning of the semester when we did long division. And here is the time that we need it. All right. So I look at the first number here in the front and I see what do I have to multiply to get this, and I write that above, and it's going to be 10x. So I'm going to write that here above the degree that matches, and then I'm going to multiply each of the items in the divisor by 10x, and then I'll subtract. So I'll have 10x cubed and then minus 10x squared, and then minus 60x. And we're going to change the signs of everything, right? Because we're going to be subtracting. And so I've got minus 5x squared and minus 60 minus 35. 25? Yeah, 20 plus 25x. And I'm going to add plus 0x here because I can continue. The remainder still has the degree that's equal to the divisor, so I continue. And I ask myself, all right, what do I need to multiply this by to get to this? And it looks like it's going to be negative x. And I'm going to put that above the, oh wait, no, it's going to be negative 5. I'm going to put that above the, this should be not 0x, this should be just a number, just 0. So this will be a minus 5. And then we multiply down, so that'll be negative 5x squared plus 5x plus 30. So I've got a plus 0 here, right? And we change the signs of everything. This changes to plus, this becomes minus, this becomes minus. So when I add down, I have 20x minus 30. Okay, so the rewrite of this fraction is 10x minus 5, that's the quotient we found, plus 20x minus 30, that's the remainder, and it goes over the divisor. So now we're going to be using just this last part is what we're going to look at for the partial fraction decomposition. That first part, that linear part, we just leave that there. So 20x minus 30 over x squared minus x minus 6. First thing that we want to do is factor the denominator. And that'll be x minus 3, x plus 2. And so then we'll split this up into two fractions. We'll have a over x minus 3 and b over x plus 2. Right. So when I'm going to multiply this by x plus 2, and I'm going to multiply this by x minus 3. So the numerators are going to end up being 20x minus 30. That's from the left-hand side. I'll have a multiplied by x plus 2, and I'll have b multiplied by x minus 3. Now, this is an example where I can use that trick I was showing you, and we'll do the trick twice. Let's let x equal negative 2. I'm choosing the item that's going to make this change to 0. When I do that, I have 20 times negative 2 minus 30 equals bx minus 3b. And in this case, hang on, what did oh, forgot to put, timeout. I forgot to put negative 2 in there. Pause. I need to go back. This is going to be, when I put negative 2 here, I'm going to have b multiplied by negative 5, right? So that's going to be negative 5b. On the left-hand side, I've got, let's see, negative 70. And so then if I divide both sides by 5, by negative 5, I get b is equal to 14. Okay, good. Now I'll go back to that equation that I had up here. And I can start over again and do the same thing. Let's do that. Let's go 20x minus 30 equals ax plus 2 plus b times x minus 3. So we already know that b is equal to 14, but just show you this process again. This time, let's let x equal 3. So when we do that, this whole thing goes away, right? And here I have 5 times a. And over on the other side, I'm going to have 60 minus 30. So 30 is equal to 5a, or a is equal to 6. So putting that all together, our original fraction was 10x cubed minus 15x squared minus 35x over x squared minus x minus 6. And we had 10x minus 5 from the long division. And then we have two fractions. We have 6 over x minus 3. And we have 14 over x plus 2. Just make sure I wrote that in the right order. What was that? Yeah, x minus 3 was first, and x plus 2 was second. So that's our answer. So these problems are really time consuming, but you do use them in calculus when you're integrating. That's something that's complex. If you have questions, you can send me an email. Have a great day.